All right, well, we have launched into this conversation with great enthusiasm. This is going to be good. Thanks, Chris. All right, next up, Matt Ruark. A lot of you probably already know or work with Matt. He's a professor in Department of Soil Science here at Madison and a faculty advisor at the UW Discovery Farms program. He's going to give you a little presentation on the water quality lessons they've learned from Discovery Farms, on-farm, real-world, practical application of some of the research generated right here. Come on up, Matt. Impress us.
And boom. All right. Thanks, everyone. So appreciate, thanks to Paul for inviting me to speak today. So broadly, the presentation title is Water Quality Lessons Learned from Discovery Farms. And so this work that I'll present here today is by no means mine. This is all a collaborative effort that ranges from our Discovery Farms directors and staff to many, many farmers throughout the state. So just a quick acknowledgement to Amber Raditz and Eric Cooley, who served as co-directors of Discovery Farms for several years now. So between, for Amber and Eric and myself, kind of formed the core management team. So Discovery Farms has been around a while, 20 plus years now. We've played a role in positioning Wisconsin to understand and tackle water quality challenges. So even the initiation of Discovery Farms existed before my time began here at the University of Wisconsin. So originally the idea was to get research onto real farms and to do actual edge of field water quality monitoring, right? And also give farmers a seat at the table to have those discussions about what are they doing, where are opportunities to improve. As we've evolved, we've built our data sets and also have worked to support farmer-led watersheds in their efforts. So as these sort of things have become more interesting and taken off, we can help address some of the issues that they're interested in. And but for those that don't know what Discovery Farms is, this is the slide that we like to put up to talk about our core values. One is that we're farmer-led. Two is we conduct on-farm research. And three is that we extend the information back out to the public. That might be farmers, but also crop consultants, the agricultural community, as well as citizens in a lot of rural landscapes. So one of the core things that we do is edge of field water quality monitoring. And so you can imagine, so this is the primary issue, and this really does revolve around phosphorus. And what makes Discovery Farms unique in how we do it is that we monitor year round. Right, so here's an example of one of our field sites, and we locate, we find a participating farmer, we find a field that we want to monitor, and then we set up these weirs and monitoring stations at the edge of the field. So here we're collecting the water as it runs off from a field and monitoring it for phosphorus or for sediment, for other nutrients. But we measure year round, so we can capture events like this, like snow melt. Right, so it's not just, so we measure during the hard times to measure. So we don't just measure during the easy times. But it gives us full seasonal, full annual budgets for phosphorus. And one of the big things that we've learned for phosphorus, I know we're not supposed to talk about phosphorus here, but this is going to be I want to compare and contrast our water quality issues to phosphorus. So the idea of phosphorus, we can find a field, we know the area of that field, and we can collect all that water that comes off. It's not easy to quantify, but it's functionally easy, if that makes sense. And we found some really interesting results. One of our key findings here is that, so the graph is total phosphorus loss from a field, and then compare that to the amount that's total phosphorus, that means that's connected to the sediment, and looking at losses that are just in the water itself, and we can find when are we seeing those big fluxes of phosphorus, what's driving big losses of phosphorus. And it was really driven by those early and into more specific, the late winter, February and March winter applications of manure. So this really identified very clearly when's the time of specific risk, and those are the times that we can start to avoid, to start lopping off, what's the low-hanging fruit. So avoiding those time periods. Okay, but as we move forward then, so we're still addressing a lot of phosphorus issues, but Dr. Kachark showed this graph as well. Nitrogen, there's still a lot of nitrogen issues in water quality that we could also work on. But nitrogen isn't primarily a surface water issue, right? It's a leaching into groundwater issue or into tidal drainage, but it's a leaching issue. So we can't monitor it the same way. We can't set up the same thing where we're collecting all the water from a field that leaches like we can with the surface water. So we've taken a different approach, is that we're going to do some assessments of use efficiency. So we're going to look at just bigger nitrogen budgets on a field, and we'll go into what that means. And the idea is, if we're going to look to improve nitrogen management or try to reduce nitrate leaching on a field-by-field basis, the first step is to know where we're starting from. And we've identified two key measures of efficiency that that can be assessed on every farm field in the state. One is, how much corn are you growing per pound of nitrogen applied? And two, what's the nitrogen balance of the field? What are your inputs and what are your exports on a field basis? And so we're going to look at, broadly, we describe these things as measures of nitrogen use efficiency. So when we use the term nitrogen use efficiency, we're using it as a broad term. But there's a lot of specific measures of nitrogen use efficiency. So one is that partial factor productivity, that's the yield for nitrogen applied. And the other one is the nitrogen balance, and that's the nitrogen applied minus nitrogen removed. So in this case, if the value is positive, we've applied more nitrogen than we've removed. So in this idea, the removal is the nitrogen content of the grain, your corn grain, or if it's corn silage, the entire plant. If it's negative, then you've removed more than you've applied. So the premise here then is that we felt that this was going to be a useful tool then to help farmers see their nitrogen, right? So the idea that around a field, if you have erosion issues, if you have compaction issues, if you have plant disease issues, if you have weeds, you can see them. But you can't see the nitrate leach out of your farm field, right? So it's not something that you can point to and it's clear that you're losing nitrogen, or there's nitrogen that's not being utilized, right? So this is the way to see it. We have to see it, so we have to see it on paper. And then our idea then is then, if farmers and crop consultants and land managers had a better sense of where they ranked relative to their peers, what their efficiency values were relative to others, then that would provide evidence on, am I doing well, or is there an opportunity to improve? Thus, we set out to benchmark our nitrogen use efficiency metrics in Wisconsin for corn grain and for corn silage. And we have a fantastic publication from Discovery Farms that has all these values in it. And what we did is, over the past 5 years, we've been out to almost 200 grain fields and almost 100 corn silage fields throughout the state. It's not a perfect distribution, but these are kind of just big parts of the state that we have a lot of collaboration in to do these calculations. How much nitrogen, getting that information from the farmer, how much nitrogen are they applying, and then we've gone in and done the sampling to calculate how much nitrogen is being removed. So we can look at efficiency and we look at nitrogen budgets. And what value we have for the farmer then is, in this document we've used this data to create categories. Are you at the low efficiency, medium to high efficiency, medium to high efficiency, or high efficiency? And based on which category you're in, then we've got some decision trees to help people think about, well, what are ways to think about it, and what are some opportunities for improvement. So that's the value to the farmer, right? So you do these assessments, and okay, here's some places where I can improve. Here's some fields that are doing well. I'm going to put some efforts on that location. But we can also use this data set, we can delve into it a little bit more to see, well, what are some drivers? So we've surveyed farmers in the state for their use efficiency. So what can we do in terms of pulling out trends in the data? So the first question we could ask is, what's the biggest driver of use efficiency? Is it yield, or is it nitrogen input? So both contribute to the assessment, right? So is it just farmers that can obtain bigger yields? That means there's more uptake. Is that driving efficiency, or is it about the amount of nitrogen that's being applied? And the answer is, it's really about the nitrogen that's being applied. So the nitrogen rate that's applied to any sort of field explains over 50% of the variation in use efficiency. So the more nitrogen that's applied means the lower the efficiency value and the bigger the nitrogen balance. When we look at yield, yield only explains 10 to 17% of that variation. So it has a role. Improving yields has a role, but not as much as nitrogen management and nitrogen input. And then what we did is that I could have shown you graph after graph looking at all of these other metrics. We had all this information about what's their soil texture, what's the pH, what's their tillage, if they use manure or not. All of these other things that go into management, we could put it all into a value. And at the end of the day, in our data set, none of these other factors really mattered in our bigger statistical model. It was simply about the nitrogen input as the driving factor. Okay, so what does that mean? On a field-by-field basis, it means improvements in efficiency, and thus the implied benefits to water quality will have to occur to improve nitrogen management. Now, that doesn't necessarily mean nutrient management in the context of following nutrient management guidelines. It's a matter of going through everything specifically on that field. In terms of rate's going to be an important one. Timing can also come into play. Crediting manure, crediting alfalfa input. So there's a bit of low-hanging fruit, but there's also a lot of additional work that we need to do. Now, at the end of the day, those measurements were simple and could be done, and they're quite valuable to, I think, field managers for decision making. But when we do these calculations, we can't really take them and use them to assess impacts to water quality. It's too variable, it's too crude of a measurement. So the next question we asked is, are there better on-farm measurements we can do? And the answer is yes. There's one additional one to take these sort of nitrogen use efficiency metrics and take an additional step. And here's the premise. So if we're growing a corn plant, this example in sweet corn, so we're looking at you think about that plant and how much nitrogen is taken up by a plant when we fertilize it. But the fertilizer doesn't get credit really for all of the nitrogen that's taken up by the plant, right? What we need to compare it against is a plant that is not fertilized, right? So what we want to know is how much extra nitrogen was taken up by a plant when we fertilize it. And that value would represent the fertilizer nitrogen that was actually taken up and actually utilized. So when we put out nitrogen onto the landscape, how much of that nitrogen ends up in the plant? So we need an assessment like this on a farm field. Now, what that takes is that we need to be able to obtain some information of that smaller plant. So we need to have small areas of the field where there isn't nitrogen applied, and we need to do nitrogen uptake measurements and calculate from there. And we found a lot of farmers that were willing to try it. It took a few years to build this data set, and we certainly don't have as big of a data set. But we can look. We have enough data now that there's some interesting results. So we've calculated this nitrogen use efficiency metric that we're calling uptake efficiency. What percent of the nitrogen that's applied to a field is actually taken up by the plant? For corn, I'm supposed to have so on the left is corn for grain, and the average value, that's 58%. So almost 60% of the nitrogen that we apply to a corn grain field is taken up, and about 50% for corn silage. So we're still at only about half, a little over half of the nitrogen that's actually applied is taken up. The other big thing to take from this figure is the big range in values, right? That there is a huge range in values that we notice in terms of how much nitrogen is being taken up. Some fields, 25% of the fields had greater than 80% of the nitrogen taken up, right? So, and 25% had less than 40%. So it's a huge range in it. So what does this mean? It means that every field is unique. As a soil scientist, we know this, right? And as a farmer, right, you probably know all these little differences in the fields that you have. All right, so we have to have this assessment on every field. There's not going to be a generalization that we can make about this. We can say what the average is in the state, but for your field, it's not 50%, right? That's just the average. What is it on your individual field? I don't know. Until we would do this sort of assessment. It does require a little bit extra effort, but it, I think, has a lot of value in really showing what that how much nitrogen is actually taken up. The idea then is then we can also flip it and then calculate how much nitrogen wasn't taken up. And we can graph it like this. So we look on the x-axis here, that's the uptake efficiency, right? And so I threw out that number of 60%. So the line going up and down, that's that 60% line. That's the average in the state. When we are looking at fields that have less than 60% efficiency, that's where we're seeing generally the amount of nitrogen not taken up is 50 pounds or greater. So that 50 pounds is just a number that we like to throw around because it does also we're getting some real meaningful nitrogen numbers, not only in terms of for water quality, but economically, right? So hitting that 60% benchmark might not be so bad because it's really tied to reducing that amount of unused N, getting that number low means less nitrate that's less likely leached to groundwater. So we're not going to know this until we have those sort of on-farm metrics. So we do have a lot more work to do in promoting nutrient management. I think there's still, a lot of low-hanging fruit for water quality improvements that can come through proper crediting of manure and alfalfa. But the other big thing that we learned is that we put a lot of effort into building this data set. And quite frankly, there's a lot of lessons to be learned, but quite frankly, it's not enough. When we talk about using big data in agriculture, this isn't big data. We've got 200 data points. It was a lot to us. It was a lot of effort to get it done. But we need to figure out how to expand it. And that's some of our goal then is we need to move into perhaps a more citizen science-based approach, build our collaborations even more to build this data set, to pull out all those other trends. What are the benefits of cover crops? What's the pros and cons of tillage in terms of nitrogen balances? And so that's going to be how our work's going to continue in the future. So with that, I'll turn it back over to Pam.